Hello everyone, it's Michael again. So today I'm going to do a walkthrough introduction Amazon Elastic File System, Amazon EFS. So in this lab it's going to introduce you to the Amazon Elastic File System, Amazon EFS, by using the AWS Management Console. After completing this lab, you should be able to log into the AWS Management Console, create an Amazon EFS file system, log into an Amazon Elastic Compute Cloud, Amazon EC2 instance that runs Amazon Linux. Mount your file system to your EC2 instance. Examine and monitor the performance of your file system. Now let's go to task 1. We need to creating a security group to access the EFS file system. The security group that you associated with a mount target must allow inbound access for TCP on port 2049 for network file system NFS. This is the security group that you will now create, configure, and attach to your EFS mount targets. So in the AWS Management Console, go to Service and to EC2. Okay, we are in EC2. Now in the navigation pane on the left, choose security group. So we're going to choose security group. Okay. Okay, so copy the security group ID of the EFS client security group to my text editor. EFS client. Security group ID. So I'll copy this. Let's save it there, put it there. Then what we're going to do is choose create security group, then configure. So because this is the walkthrough, I just save it on the web browser right here, the security ID. But for security purposes, you should always save it on your local file. But because this is just a walkthrough lab, just for convenience, just save it here in this Google search browser. So now back, we want to choose create security group. So create security group, and then in security group name, we're going to choose EFS mount target. For the description, we're going to say inbound EFS access from EFS client. So for the VPC, we're going to choose left VPC. Okay. Under the inbound rule section, choose add rule, then configure type NFS. Okay. For the source to be custom, and in the custom box, paste the security group ID that you just copy into your text editor, and put it here. This is the one. and then choose create security group. Awesome, security group was created successfully. Now task 2 we're going to create an EFS file system. EFS file system can be mounted to multiple EC2 instances that run in different availability zones in the same regions. These instances use mount targets that are created in each availability zone to mount the file system by using standard NFS v4.1 semantic. Um, you can mount the file system on instances in only one virtual private cloud VPC at a time. Both the file system and the VPC must be in the same regions. So on the service menu, choose EFS. Now choose create file system. In the create file system window, choose customize. On step 1, uncheck enable automatic backup. And for the lifecycle management, select none. Okay, let's see. Lifecycle management, select none. Lifecycle management, so it should be none for everything. Okay. In the tag section, configure tag sections. So configure key is gonna be name, right? Values will be my first EFS file system. Could be our value. Okay. And then choose next. Next, for the VPC, select lab VPC. Okay. Detach the default security group from each available zone mount target by choosing Xbox checkbox on each default security group. Detach the default security group from each available zone mount target by choosing X checkbox on each default security group. Okay. Attach the EFS mount target security group to each availability zone mount target by selecting each security group's checkbox. Okay. Choose the EFS mount target. EFS mount target. Okay. A mount target is created for each subnet. Your mount target should look like the following example. The diagram shows two mount targets in the lab VPC that use the EFS mount target security group. In this lab, you should be using the lab VPC. Okay, so lab VPC security group mount target EFS mount target. Okay. Now choose next. On step 4, review your configuration and choose create. Okay. So we created our first EFS file system. So congratulations, you have created a new EFS file system in your lab VPC and mount targets in each lab VPC subnet. In a few seconds, the file system state of the file system will change to available, followed by the mount target 2 to 3 minutes later. Proceed to the next step after the mount target state for each mount target changes to available. Choose the screen refresh button after 2 to 3 minutes to check its progress. Note that you may need to scroll to the right in the file system pane to find the file system state. Available. Awesome. Now, task 3 is to connect to your EC2 instance via SSH. In this task, you will connect to your EC2 instance by using secure shell, SSH, Microsoft Windows user. This is for my Microsoft Windows user. This is for us, Mac OS and Linux user. The instructions are specifically for Mac OS or Linux users. So if you have Windows users, skip to the next task. This is our right instruction for Mac OS. So above this instruction that you are currently reading, choose the details drop down menu and then select show. Let's see, above the instruction you are currently reading, choose details. Choose detail. Okay. Choose show. So a credentials window open. Choose download PEM button and save labuser.pem file. Okay, show download PEM. Alright. So note that the EC2's public IP address, if it is displayed, exits detail pane by closing X. Okay. Now open the terminal window and change directory to the directory where the user.pom file was downloaded by using cd command. Okay. So go to a terminal. cd / download. Open the terminal window and change directory to the directory where the file was downloaded by using cd command. Yeah, be sure that's save in here in the download. So download. Yep, it's right in here. So terminal. So run the following command: replace public IP with EC2 public IP address that you copied earlier. To find the address on a green instance, return to EC2 consoles and select instance. Select the instance that you want to connect to in the description tab and copy the value. Okay. So go back to EC2 instance. Let's go to EC2 instance. Go to instances. Okay, so this is the ID that we want. Public IP. Replace the IP with the EC2 public IP. This is public IP right here. This is what we need. So run the following command. Let me go back to CD download. This is download. Download, yes. CD download. Now we're inside download. Run this command. Let's see. Can be established. Print is this key is not known by any other name. Are you sure you want to continue connecting? When you prompt to allow the first connection, press enter yes. The authenticity of the host can be established. Key fingerprint is this key is not known by any other name. Are you sure you want to continue connecting? Yes. Okay. Now we're going to creating a new directory and mounting the EFS file system. Amazon EFS support the NFS v41 and NFS v 4.0 protocols when it mounts your file system on EC2 instances. Though NFS v4.0 is supported, we recommend that you use NFS v4.1 when you mount your EFS file system on your EC2 instance. You must also use an NFS client that support your chosen NFS v4 protocol. The EC2 instance that was launched was part of this lab include an NFS v1.4 client, which is already installed on it. So in your SSH sessions, make a new directory by entering sudo mkdir EFS. Which command did I enter? Nope, that was not. So sudo mkdir EFS, and then back to AWS Console Management. In Service menu, choose EFS. Choose my first EFS file system. In the Amazon EFS console, on the top right corner of the page, choose attach. To open the Amazon EC2 mount instructions. Copy the entire command in the using NFS client sections. The mount command should look something similar to this example. Okay. In your Linux SS sessions, mount your EFS file system by placing the command and enter. Okay. Get a full summary of the variable and udisk usage by entering sudo df -ht. Okay. Use available. This following screenshot is an example of the output from the following this file system command. Notice the type and size of your mounted EFS system. Okay. So it's right here. Now task 5 is we're going to examine the performance behavior of your new EFS file system. Examine the performance by using the flexible IO. Flexible IO file is a synthetic IO benchmarking utility for Linux. It is used to benchmark and test Linux IO subsystems during boot. File was automatically installed on your EC2 instance. Examine the write performance characteristic of your file system by entering this command. The file command will take about 5 to 10 minutes to complete. The output is going to look like the example in the following screenshot right here. So make sure that you examine the output of your FIFO command, specifically the summary statics information for this write task. So it should look something like this. Starting one process and laying out IO files. We would have something similar like this. Dev submit complete issues to latency. So monitor performance by using Amazon CloudWatch. So in AWS Management Console, go to Service and go to CloudWatch. In the navigation pane on the left, choose Metric. In All Metric tab, choose EFS. And choose File System Metric. So at the moment, there's no alarm. Select the row that has permitted throughput metric name. You might need to wait 2-3 minutes and refresh the screen several times before all available metric include permitted throughput calculated populate. Okay, so it shows right here. It's our graph. So byte per second. On the graph, choose and drag around the data line. If you do not see the line graph, adjust the time range of the graph to display the period during which you ran the file command. Okay. Pause your pointer on the data line in the graph. The value should be 105. Right here. 105. Okay. Yeah. Yep, the value should be 105. The throughput of Amazon EFS scales as the file system grows. File-based workloads are typically spiky. They drive high levels of throughput for short period of times and low level of throughput the rest of the time. Because of this behavior, Amazon EFS is designed to burst to high throughput levels for periods of time. All file systems, regardless of size, can burst to 100 MB per second of throughput. For more information about the performance characteristic of your EFS file system, we can look at the documentation on Amazon Elastic File System. So in all metric tabs, uncheck the box permitted throughput. Okay. Select the box for data write IO byte. Okay, I don't see anything here. Oh, it says something right here. If you not see the data, write I will byte in the list of metrics. Use file system metrics to search for it. Choose the graph metric tab. Choose the graph metric tab. On statistic column, select sum. Okay, this is what we got back from earlier command. On the period, so back to our task. So on the period column, select 1 minute. Period column, select 1 minute. Okay, now we see something. Because your pointer on the peak of the line graph, take this number in byte and divide by the duration in seconds, 60 seconds. The result gives you the right throughput BS be byte over second of your file system during your test. The throughput that is available to a file system scale as a file system growth. All file systems deliver a consistent baseline performance of 50 MB per second per TIB of storage. Also, all file systems, regardless of size, can burst to 100 MIBs. File systems that are larger than 1 terabyte can burst to 100 MIB per second per TIB of storage. As you add data to your file system, the maximum throughput that is available to the file system scales linearly and automatically with your storage. File system throughput is shared across all EC2 instances that are connected to a file system. For more information about the performance characteristic of your EFS file system, you can look at the Amazon Elastic File System documentation. So congratulations, you have created an EFS file system, mounted it to an EC2 instance, and ran an I/O benchmark test to examine its performance characteristics. And that is it for today lab walkthrough. Thank you so much for everyone to watching my video, and have a good day.